All right, let's go ahead and finally get to working with binomial random variables. So in the previous videos, we went ahead and stated that binomial random variables are essentially characterized by four conditions, experiments that have four conditions, and those were fixed number of trials, condition two, independence of those trials, only two potential outcomes, and then finally the probability of success at each trial remaining the same. What we need to do is we need to make sure that we know the parameters. So the parameters are essentially values that you need to successfully describe something fully. And in this case, we need to describe n, the sample size, and p, the probability of success. And if x is the number of successes, right, how many times you observe the success in that sample of size n, then we go ahead and write that x. So this is the notation that we'll use, the random variable is distributed, and so that tilde right there means that it describes the distribution. So it has distribution. And I'm going to put B for binomial. You could also write it out, binomial, comma, and P. And you essentially have everything that you want to know about this random variable. So from the example where we said the number of people who respond favorably to a commercial, there was NP. We go ahead and use StatCrunch. We go to stats, calculators, binomial, and we input and P. And doing so produces the distribution as a graph of this random variable. So on the x-axis, we have the possible values. And on the y-axis, we have the corresponding probability. And we can see that our graph with these little sticks here, they're all positive. And there's a peak out of roughly 16. Now, technically, this actually does extend all the way out here because remember that the number of successes could be 9, could be 8, it could even be 0. It's just that the probability is so small that StatCrunch has decided not to show it because you can tell how small the probability already is for 10 successes, assuming that distribution. All right, so now that we have the distribution, we also go ahead and describe the expected value. And it's got the same interpretation as previous videos. So the expected value still describes the long-term behavior of the random variable. And it still has the same formula. So remember that the formula for expected value was the product of the outcome times the corresponding probability. And you add that up over all possible values of the random variable. Now, it turns out that because of the probability formula that we had, which we're not using, by the way, because we're using StatCrunch, that all simplifies to just simply n times p. So you can show this mathematically, that the expected value, if your random variable has binomial distribution, so if x is binomial random variable, n comma p, then the expected value is simply the product of n and p, and the standard deviation is the square root of the product of np and 1 minus p. So let's go ahead and just work with this pretty easily. So it's very easy to work with random variables once they're named. So a binomial experiment is conducted with the given parameters, compute the probability of x successes. So notice that this says that the number of successes is binomial with n is 15 and p is 0.85. So now they basically say, find the probability that your number of successes here is exactly 12. So little x here is 12. Now you could use the formula, but we're not going to go ahead and do that. We're simply going to use StatCrunch. So remember that in StatCrunch, you go to stats, calculator, binomial. You got to input the value n. So we have to check what that was. It was 15 and 0.85. So n is 15 and p is 0.85. Here is the picture, and I'm going to change this to x equals 2. And notice that was it 2? Sorry. Because it's very, very small. Yeah, probability of x being 2. So it's ridiculously small. Oh, I'm sorry, not 2, 12. So let's fix that. All right, so that probability is 0.2184. All right, and there you have it. That's how we find probability. Now, let's go ahead and work on getting the expected value of this random variable. So the expected value is n times p. So in this case, it's 15 times 0.85. Throw that into a calculator, and you'll get 12.75. So we're done with that. And then finally, sigma is the square root of n times p times 1 minus p. Okay, so go ahead and find what that gives you. All right, so I would actually recommend that you use the decimals calculator. You don't need a calculator, but you cannot use your phone when you take assessments. So here is the decimals calculator, decimals.com/scientific. And we've got n multiplying with p, multiplying with 1 minus p. And then we take the square root of that. So there's our answer, 1.383. All right, now remember that this tells you that the expected value of this random variable over many, many times is 12.75. So on average, you're going to get 12.75 successes. So if you do this experiment 10 times, so you ask 15 individuals 10 different times, then you multiply this by 10. So that's 127 successes over that span, approximately. All right, the rest of these are just as easy, so go ahead and find these probabilities. I'll leave it for you. The random variable x is less than 2, and the probability that a random variable x is greater than or equal to 1. Don't forget to update n and p for all of these problems. So you got to change n and p every single time that you're using the applet. All right, thank you for joining me. That's, in essence, all we got to do. So in the next video, we'll do a complete problem.